Okay, so we're now cracking into homework set 39. In the previous homework set, we were solving side-side angle triangles and making use of the law of the sines. In this case, we're going to solve side angle side triangles, making use of the law of the cosine. So the law, and this is problem 16 on page 538. You have problem 15 as a sister to do. So just quickly, the law, I like the law of the cosines because to me it's kind of the generalized Pythagorean theorem. Yeah, because I think either you realize by now, or if you don't, I probably corrected you by now, that the Pythagorean theorem applies only to right triangles. If you don't understand it, put your hand over your heart and repeat after me. Pythagorean theorem applies only to right triangles. The law of the sines applies to any type of angle. Here's a non-right triangle, angle C, and as it turns out that C squared is equal to A squared plus B squared. Kind of looks like the Pythagorean theorem. It's not, because it has this term. But this is the law of the cosines, of course, that C squared is equal to the sum of the squares of the side minus 2 times their product times the cosine of the included angle. Wow, I said that well. So we're going to make use of that in this particular problem. Problem 16. Problem 16 says you're dealing with this triangle right here. And it is a triangle that has got some angles, and it's got some sides, and they tell you what the sides are. They say B is equal to 3. They say A is equal to 4. And they say C, what can't C be equal to? If it's not a right triangle, it can't be equal to 5. It says C is equal to 4. Well, it's an isosceles triangle. It doesn't look it when I drew it, but there you have it. And the instructions is solve every triangle. So, oh, look at us. We've got sides. We've got no angles. But you can get them pretty quickly. Because if I apply the law of the cosine to angle A, apply law, I'll spell it, of the cosine to angle A. Okay? This is the angle included between B and C. The side opposite is A. So the way in this manifestation you would say that A squared is equal to B squared plus C squared minus 2BC sine of, what's the included angle? A. Okay? So we happen to know A, 4 squared. We happen to know B, 3 squared. We happen to know C, 4 squared. We happen to know B is 3 and C is 4. And there's the sine of A. So I'm going to isolate sine of A here real quick. I got a 4 and a 4. I'm going to put this stuff over there. And this is going to be 6 times 4 is 24 sine A is equal to 9. Sine A is equal to 9 over 24, which if I divide top and bottom by 3, I get 3/8. And if I take 3 and divide it by 8, and I take the arc sine, watching that everything is, all of the domains are lined up properly, I'm going to find that A is equal to 22.0 degrees. Okay, let's circle that for a moment. Great, let's find another one. This was 1, 2. Let's go apply the law of the cosine to angle B. When I do that, angle B is stuck between A and C, and it's across from side B. B squared is equal to A squared plus C squared minus 2AC sine, what are we doing? B. I did sine. Duh. did sine. Oh, back up. Sorry, this is a cosine right here. Sorry, this is a cosine right here. This is a cosine right here. There's a reason this is called the law of the cosine. Let me put a B there. Make this a cosine, make that a cosine. Cosine A, cosine A. Don't tell anybody about this, please. Okay, sorry, I got to take the arc cosine over here. So I get 3, enter, 8, divide. Take the arc cosine. Yikes. And I get 67.98 degrees. Ugh, it just creeps me out that I did that. Let's do it again here. What is B? B is 3 squared is equal to 4 squared plus 4 squared minus 2 times A times C times the cosine of B. Okay, I got to isolate cosine of B again, so I can take the arc cosine and find B. How am I going to do that, for crying out loud? I'm going to put the 2 times 4 times 4. I'm going to put the 32 B squared over here. 32 cosine B over here. I'm going to put this 9. This is 16 plus 16 is 32. 32 minus 9. I used to be able to do that. Is that 23? Is that 23? 32? I think it is. So cosine of B is going to be equal to 23 all over 32. And that's going to say that B equals, taking a 23, I'm taking a 32, I'm dividing, I am taking the arc cosine, right? Let's do that, and I'm going to get 44.05 degrees for B, and then how will I get C? I could apply the law of cosines, or instead I could say that angle C is equal to 180 degrees minus angle A minus angle B, and then very quickly, not that quickly, 180 plus, I would get that C is 67.97 degrees. And I believe that constitutes the solution to this triangle. 70, 71, 40 plus 40. Okay, let's go with it.